So recently, Nobel Prize winner Adam Rees revealed that we may have gotten the universe completely wrong. And he's not the only one making this claim. Following the recent discoveries by the James Webb Space Telescope, many renowned scientists are also saying that the universe is far stranger than we previously thought. Just a few days ago, we discussed MOM-Z14, the most distant galaxy ever discovered, which formed far too early in the universe's history. That alone challenged everything we thought we knew about how galaxies evolve. But now, the James Webb Space Telescope has uncovered something even more worrying. This latest discovery is not just surprising, it's deeply unsettling for astronomy. Recently, astronomers have uncovered a colossal barred spiral galaxy named J0107a, dating back 11.1 billion years, which is just a fraction of the current age of the universe. Using the ALMA Observatory and NASA's James Webb Space Telescope, researchers discovered that J0107a has a well-defined spiral structure with a central bar much like our Milky Way. However, it's over 10 times more massive and is forming stars at an astonishing rate, hundreds of times faster than our galaxy. What makes this discovery truly astonishing is that the galaxy shows an organized structure during a cosmic era when most galaxies were still chaotic and unsettled. Even more surprising, unlike modern galaxies with such intense star formation, J0107a shows no evidence of mergers or collisions. Its calm, isolated formation in such a turbulent time defies our current understanding of how galaxies evolve. But wait, in addition to this, what the James Webb Space Telescope recently captured in one of its deepest views of the universe is now igniting intense debate among scientists. This ambitious observation reveals spinning arcs of light representing galaxies formed during the cosmic dawn, a period when the universe was just a few 100 million years old. And with this image, scientists have realized something striking. The deeper we look into the early universe, the more unexpected and puzzling surprises we continue to uncover. Scientists previously believed that the James Webb Space Telescope would reveal how the universe looked in its early days, how galaxies formed after the Big Bang, and how small galaxies gradually grew over time. But what Webb has just uncovered at the very beginning of the universe has created a storm in the field of astronomy. A growing number of researchers are now beginning to suggest that it's as if we are seeing an entirely different universe, one filled with enormous galaxies and mysterious cosmic structures that defy everything our current theories predict. So what exactly did Webb see in its latest observations? And why are scientists now saying that Webb might be looking at a completely different universe? Back in 2016, NASA's Hubble Space Telescope made a groundbreaking discovery. It identified a galaxy called GN-Z11, which at that time became the most distant and oldest known galaxy ever observed. The light from this galaxy took 13.4 billion years to reach us, meaning we were seeing it as it was just 400 million years after the Big Bang, when the universe was only 3% of its current age. But that wasn't the only surprising part. GN-Z11 was found to be unexpectedly bright, large, and actively forming stars, even though it existed so early in the universe's history. This puzzled scientists because, according to the standard cosmological models, such a massive and mature galaxy shouldn't have existed so soon. Still, many scientists thought GN-Z11 might just be a rare exception or a cosmic fluke. That's because most other galaxies observed by Hubble at similar distances up to redshift of 10 fit perfectly with predictions from our cosmological models. So, there wasn't much pressure to rethink our theories. However, everything changed in 2022 when the James Webb Space Telescope started its science operations. Designed to look deeper into space and further back in time than ever before, Webb quickly began revealing a flood of surprises. In its very first deep field image, Webb detected several galaxies that broke previous records for distance and age. One of them, named JWST-GS-Z14-0, was found to have existed just around 290 million years after the Big Bang, even earlier than GN-Z11. This discovery sent shockwaves through the astronomy community. If GN11 wasn't alone, and other galaxies just like it, bright, massive, and early, were showing up, it meant something might be seriously wrong with our current understanding of how galaxies form and evolve. As Webb Telescope continued its observations, things got even more puzzling. It began finding even more distant and mysterious objects. What's more troubling is that some of these objects are so luminous and large that scientists aren't even sure what they are. Are they galaxies? Supermassive black holes? Something else entirely? Whatever they are, they don't fit into any of our current theories. These objects appear to have existed as early as 280 million years after the Big Bang, or even sooner. The biggest problem is that our standard models of the universe don't predict this. According to those models, there simply shouldn't have been enough time for so many large, bright structures to form. Well, until recently, the most distant and oldest known galaxy was JADES-GS-Z14-0, which existed just 290 million years after the Big Bang. This galaxy still puzzles scientists because its enormous size so early in the universe's history challenges current understanding of galaxy formation. But wait, just when scientists thought they had seen it all, Webb just spotted something even more puzzling. An object named MOM-Z14, dating back to just 280 million years after the Big Bang. MOM-Z14 exhibits a redshift of 14.44, surpassing the previous record holder. This discovery completely defies our current understanding of the early universe. Scientists still don't know exactly what it is: galaxy, black hole, something else entirely. But whatever it is, it shouldn't exist this early, according to our current models. By the way, the search for early massive galaxies does not end at a redshift of 15. Scientists have found a large number of galaxies at redshifts of 15 and beyond. But some of these galaxies show multiple redshift values that need to be revised again with further spectroscopic testing. And in new research, scientists suggested that if even a fraction of the candidates are actually at redshifts greater than 15, it means there is a significant tension with the existing theoretical models. With each new discovery, scientists are uncovering galaxies that are not only far more massive, but also more structured than our Milky Way, appearing just a few 100 million years after the Big Bang. The sudden emergence of these bright, well-formed galaxies in the early universe is raising serious questions. Their existence hints that the cosmos may hold far more surprises than we ever imagined, especially as we continue to peer deeper into its ancient past. Many scientists now argue that our standard cosmological models work well in explaining the universe's evolution, up to a redshift of 10. But the moment we look beyond that into the earliest stages of the cosmos, the universe begins to look dramatically different from what our models predicted. So far, no existing theory can fully explain what we're observing in those first few 100 million years after the Big Bang. Well, it's not just about galaxies existing far earlier than we expected. Scientists have also observed that the expansion rate of the universe isn't uniform. This suggests that the mysterious dark energy believed to be driving the universe's expansion is actually evolving and weakening over time. This discovery from the DESI collaboration challenges one of the core assumptions of the standard cosmological model that dark energy is constant. In fact, It even proves Einstein wrong on one key idea that the expansion rate or the cosmological constant is truly constant. Picture the universe as a vast, unfolding story, where the first chapters were supposed to be simple and slow. Yet here we find fully formed epics already written in the opening pages. All of these recent findings are beginning to suggest something profound. We might be missing a fundamental piece of the puzzle when it comes to understanding the universe. Or perhaps something truly strange happened in the early universe that we still don't fully grasp. Our theories have no clue about it. And if we look as far as we can with the telescopes we have right now, up to only a few 100 million years after the Big Bang, we see objects like Virgil, where a supermassive black hole sits at the center of an infant galaxy, growing far faster than any model allows. One of the first galaxies to form already hosts a colossal black hole at its heart. So that really only emphasizes the problem of explaining how these things form, because there really isn't that much time between the Big Bang and these first galaxies that already have these supermassive black holes at their centers. Until now, by studying the local universe and tracing it all the way back to the cosmic microwave background radiation, which sits at a redshift of about 1,100, scientists concluded that the universe began as a hot, infinitely dense point, commonly known as the Big Bang. But the shocking discoveries from the James Webb Space Telescope are now forcing scientists to reconsider that view. The unexpected presence of massive structured galaxies just a few 100 million years after the Big Bang doesn't fit well with standard cosmological models. As a result, some scientists are exploring alternative theories that go beyond the traditional Big Bang. One such idea suggests that other universes may have existed before ours, and that they might have even interacted with our universe in its earliest moments. Some speculative models propose the existence of parallel universes filled with dark matter, possibly connected to ours through extra dimensions, as proposed in string theory and brane world cosmology. Another fascinating theory suggests the existence of a mirror universe, a cosmos running backward in time symmetric to our own. Among all these theories, one gaining significant attention is conformal cyclic cosmology, proposed by the renowned physicist Sir Roger Penrose. According to this theory, our universe is just one in a long chain of universes, each emerging from the death of the previous one in an endless cycle of cosmic rebirth. Penrose even claims there may be faint imprints or remnants of a previous universe visible in the cosmic microwave background radiation, subtle patterns that could hint at events from a pre-Big Bang cosmos. Interestingly, the early galaxies discovered by the James Webb Telescope may align with predictions from models like conformal cyclic cosmology, adding weight to the idea that our universe might be far older or far more complex than we ever imagined. Imagine standing at the edge of everything we thought we knew, only to realize the horizon keeps shifting farther out, pulling us into depths we never prepared for. These revelations aren't just data points on a graph. They are cosmic whispers urging us to question the very fabric of reality, to wonder if the Big Bang was truly the beginning or merely one verse in an eternal symphony. The James Webb Space Telescope hasn't just shown us farther. It has shown us differently, forcing a reckoning with models that once felt unbreakable. Yet in that uncertainty lies the thrill of discovery, the human drive to chase truth across billions of light years. What if the universe we see today is only a shadow of a grander design, where dark energy fades like a dying star and galaxies bloom in defiance of time itself? The tension in our measurements, the impossible structures in the dawn of creation, the hints of cycles beyond our own, all point to a cosmos alive with possibility, inviting us to rewrite the story we tell about our origins. As we stand on the brink of this new understanding, one thing becomes clear. The universe refuses to be boxed into our expectations. It demands humility, curiosity, and relentless wonder. Nobel laureates like Adam Rees remind us that science thrives not on certainty, but on the courage to admit when the map no longer matches the territory. Every new photon captured by Webb is an invitation to dream bigger, to explore deeper, and to embrace the unknown as the greatest teacher. The early galaxies, the evolving dark energy, the echoes of possible pre-Big Bang echoes, they don't diminish our place in the cosmos. They elevate it, showing that we are part of a story still unfolding, rich with mystery and potential. If this glimpse into the universe's hidden truths has stirred something profound within you, if it has made you pause and marvel at how much remains to be discovered, then let that spark ignite action. Subscribe to stay connected to the latest revelations that reshape our reality. Comment below with your thoughts. Do you believe we are witnessing a new cosmology unfolding? Share this with friends and fellow explorers who crave the awe of the unknown. Together we can keep pushing the boundaries of what we know, turning questions into quests and wonder into wisdom. The universe is calling. What will you answer?